Hello everyone, welcome to my channel. In this video, I am going to discuss about the chapter real number. Before going to that, we have to know about classification of numbers. Numbers can be classified into two types, real numbers and imaginary numbers. And real numbers are also classified into two types, rational number and irrational number. And rational numbers are again classified into natural number, whole number, integers, even number and odd number, prime number and composite number. Like in this way, we are classify the number into different types. Let us see one by one. Positive result that we called as a real number. For example, I am taking 2, I am squaring this number, we get a result 4. That is the positive result. When we squaring a number, we get a positive result that we called as a real number. I am taking another example, minus 2. I am squaring minus 2. Minus 2 whole square means minus 2 into minus 2. Minus into minus plus 2 into 2 is 4. So when I am squaring this minus 2, we get a positive result plus 4. That we called as a real number. Which means a real number means the numbers which are squaring give a positive result. Any number if we take any number, squaring that number, we get a positive result, then we called as a real number. Okay, now let us see imaginary number. Imaginary number means all non-real numbers are called imaginary number. I am already told you that what is real number. When we squaring, we get a real number. Imaginary number means when we squaring a number, we doesn't get a positive result. For example, square root of minus 2 whole square. Square root of minus 2 whole square. I am squaring the number root of minus 2. We are getting a square root and 2 is cancel. We are getting minus 2, which means we are getting the when I am squaring this number, we get a negative result. These type of numbers are called imaginary number. Okay, next let us see next one, rational number. Rational number, the number which can be expressed in the form of p by q. The numbers which can be expressed in the form of p by q. P and q belongs to I. I means integer. Integer means any numbers from 0 to any number. Positive and negative numbers are called as integers, and q not equal to 0 are called rational number, and it is denoted by q. Is denoted by q. Rational numbers is for example 3 by 5, 3 by 5, 4 by 9. Like these numbers are called rational numbers. Let us see the next one. Natural numbers. Natural numbers, all counting numbers starts from 1. All counting numbers, any numbers without negative numbers, all the positive numbers except 0, that we called as a natural number. For example 1, 2, 3, 4, like that. These numbers are called natural numbers. Okay, let us move on to next one, whole number. Whole number is a all natural number. All natural number including 0. Already told you that natural number is starts from 1 2, 3. These numbers are natural number, right? Whole number is including 0. Including 0, 0, 1, 2, 3. These numbers are called whole number. The next one is integer. The next one is integer, all positive and negative whole number. We already know that whole number starts from 0 and 1 and 2, 3. These are the whole numbers, right? Integer means all positive and negative numbers. All positive. These are positive numbers. So now positive and negative. Positive and negative. Like this way, all positive and negative numbers are called whole number. The number which starts from 1 that we called as a natural number, including 0 that we called as a whole number. Then all positive and negative numbers of whole number are called integer. The next one is even number and odd number. Even number, the numbers the numbers which are divisible by 2. For example, 2, 4, 6, 8. These numbers are called even numbers. The numbers which is divisible by 2. We can divide these numbers by 2. Those numbers are called as even number. Odd numbers, the numbers which are not divisible by 2, which means the numbers which cannot be divisible by 2, that we called as an odd number. For example, 1, 3, 5, etc. These numbers are called odd number. These numbers cannot be divided by the number which is divisible by odd 2 numbers. The next one is a prime number. The number other than 1 which have exactly 2 factors, 1 and itself. I am explaining this with the example. I am taking some numbers like 2, 3, 4, 5, 6. I am taking some numbers. The number 2 is divisible by 1 and 2 also, right? The number we can divide this number by 1, so we get a 2, and 2 divided by 2 we get a number 1. So this number can be divided by 1 and the same number, 1 and itself. So this is the prime number. The number other than 1 which have exactly 2 factor, 1 and itself. This number have a 2 factor, that we called as a prime number. The next one is 3. 3 can be divided by 1, which is equal to 3, and 3 is divided by the same number which is equal to 3. Other than 1 and the same number, it doesn't divide with any other number. These numbers are called prime number. I am taking 4. 4 divided by 1 which is equal to 4, and 4 also divided by 2. 2 ones are 2. 2 twos are 4, which is 4 by 1 and 2 also. Again the same number, 4 divided by 4. 4 ones are 4. 4 ones are 4. We get the result 1. So the number 4 can be divided by another number also. The 1 and the same number, and also another number, which means it have a 3 factors. 3 factor is 1, which is having a 3 factor, 1, 2 and 4, like not a 3. The number which is having the number which is 4 having factor 1, 2 and 4, which have exactly 2 factors, right? 1 and itself. The numbers which is divisible by 1 and itself, those numbers are called prime number. If suppose it has a more than 2 factor, that we called as a composite number. Now we doesn't call that as a prime number. The prime number only have 2 factors, 1 and 2. Okay, let us see next one. Composite number, the numbers which is divisible by more than 2 factor. For example, I'm already told you that 4, the number 4 can be divisible by 1, and it can be divisible by 2 also, which means 2 ones are 2, 2 twos are 4. So 4 can be divisible by the same number 4. 4 ones are 4, 4 ones are 4. So the result is 1. So number which is divisible by more than 2 factor. Here we are having a 3 factors, 1, 2 and again 4. These numbers are called composite number. I am taking another one example, 6. The number 6 can be divisible by 1. 1 ones are 1 6. So the result is 6. 6 also divisible by 2. 2 ones are 2. 2 threes are 6. The result is 3. Again 6 can be divisible by 3 also. 3 ones are 3 twos are. So we get a result 2. Again we can divide this number by 6 itself. 6 ones are 6 ones are, which is equal to 1. Here this number having a factor 1, 2, 3 and 6. The number which is divisible by 1 and itself, and also another 2 factors also. This numbers having a more than 2 factor. More than 2 factor. These type of numbers are called composite number. The numbers which is divisible by more than 2 numbers, that we called as a composite number. The number which is divisible by 1 and itself are called prime number, which means the numbers which have only 2 factor, the numbers which have only 2 factor, that we called as a prime number. The numbers which have more than 2 factor, that we called as a composite number. Okay, let us see the next one. Irrational numbers. The numbers which cannot be expressed in the form of p by q, that we call as irrational numbers. I am already told you that rational number, the number which can be expressed in the p by q, in the form of p by q, that we called as for example 2 by 3, 3 by 7. These are rational numbers. These are rational numbers. The numbers which cannot be expressed, that we called as irrational numbers. For example, root 2, root 3. This is a irrational number. These are irrational numbers. Suppose if we take root 4, we can write root 4 as a 2. So this is not a irrational number. It is a rational number. The numbers which cannot be expressed in the form of p by q, those numbers are called
the numbers which
numbers.
Cannot be expressed in the form of p by q, that we called as a irrational number.
2 by 1 also. So this is a rational number. Okay, let us see the next concept. So now let us see the chapter real numbers. In this chapter we want to know some concepts, that is if we want to solve the problems of this chapter, we want to know these concepts. The first one is a real number.
The first one is a prime number. The prime numbers means the numbers which is divisible by 1 and itself. Prime number having only 2 factors, that we called as a prime number. And a composite number. Composite number means numbers which is divisible by more than 2 factors, which means 1 and itself, and having another number also, that we called as a composite number.
More than 2 factors, that we called as a composite number. And we want to know this chapter. In this chapter, fundamental theorem of arithmetic, HCF means highest common factor, LCM lowest common multiple, then the relation between the two positive integers, and HCF and LCM. Okay, now let us see one by one. I am already told you that prime number, the prime number is which having a 2 factors, the numbers which are having a 2 factors, that we called as a prime number. Composite number is the numbers which is having a more than 2 factor, that we called as a composite number. Okay, now let us see fundamental theorem of fundamental theorem of arithmetic. Firstly, we have to know about the definition of fundamental theorem of arithmetic. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occurs. I am explaining this using a example. I am taking the number 96. 96 is a composite number, right? We can factorize this number and this number with a prime numbers. Factorize this composite number by prime numbers. 2 4s 6, 2 8s 16, 2 2s 4, 2 4s 8, 2 1s 2, 2 2s 4, 2 6 12, 2 3s 6, 3 1s 3. So 96 can be written as 2 1 2 3 4 5 5 2s into 3 power 1. The statement says that every composite number can be expressed as a product of primes. This is the composite number, right? This composite number expressed as a product of prime numbers. This composite number can be factorized using the prime number. Prime numbers, it is a multiple of prime number, right? This composite number is a multiple of prime number. The statement says that every composite number can be expressed as the product of prime. This composite number can be expressed as a product of prime. This factorization is unique and order in which prime factors occurs. This order, the power of the factorized prime number, this power is also a prime number, that we called as a fundamental theorem of arithmetic. Simply we can say that composite number is a product of prime numbers. Okay, let us see the next one, HCF. HCF is a highest, HCF full form of HCF is a highest common factor. Full form of HCF is highest, full form of HCF is highest common factor, and the definition of HCF is a product of the smallest power of each prime number in the numbers. I am taking the example, then explaining what is how to find the HCF, the definition of HCF. Example, I am taking example, find the HCF of 6 and 20. Here I am factorizing the number 6. 2 3s 6. 6 is equal to, we can write 6 is equal to 2 power 1 into 3 power 1. I am taking 20, factorizing this number. 2 10s are 20, and 2 5s are 10, then 5 1s are 5. So we can write 20 as 2 power 2. Here 1 and 2, right? 2 power 2 into 5 power 1. So the statement says that product of the smallest power of each common prime factor in the number, power of each common factor, each common prime factor here in these two numbers. Okay, now let us see HCF of 6 comma HCF of 6 comma 20, which is equal to a common factor is the statement says that power of each common factor. Firstly we have to write the common number. common number is in these two composite number, when we factorizing we get a common number is 2. And the product of smallest power of each common prime factor in the number, product the smallest power, the common number is 2 and the smallest power is 1. Smallest power is 1, right? So 2 to the power 1. So this is the HCF of 6 comma 20. HCF definition of HCF is a product of the smallest power of each common prime factor in the number. In the number 6 and 20, when we factorizing this number, we get a product of prime numbers, right? The number 6 having a prime factors, and the number 20 also having a prime factor. In the HCF says that common factor, prime factor. In these two numbers, we are having a common factor 2 and 2. So that number we have to write. Then smallest power, they say that smallest power, the smallest power is 1. So 2 power 1 is the HCF of 6 comma 20. Like in this way we have to find the value of HCF. Okay, now let us see HCF. Sorry, LCM. LCM means lowest common multiple. The lowest common multiple. Okay, let us see the statement. Product of the greatest power of each prime factor involved in the number. Involved in the number. I am explaining using the example. Example, find the LCM. Find the LCM of 6 and 20. The number 6 can be expressed as 2 3s are 6, and 20 can be expressed as 2 10s are 20, 2 5s are 10, and 5 1s are 5. So 6 can be written as 6 is equal to 2 power 1 into 3 power 1. Again 20 can be written as 2 power 2 and 5 power 1 in the statement of LCM. So we have to, if we want to write LCM of 6 comma 20, 6 comma 20, we can write the product of greatest power of each prime factor. In this statement they are given each prime factor. So each prime factors means we have to write all the factors here 2 and 3 and 5, and a greatest power of each prime factor. Greatest power of each prime factor means in the each prime factors we have to write greatest powers. Here I am writing, so this is the 2 into 3, 3 into 5, and greatest power is in comparing these two numbers we get a greatest power is 2. So we are writing 2 power 2. Here we have only 3 power 1. So 3 power 1. Here 5 power 1. 5 power 1. When we multiplying 2 into 2 and into 3 into 5, we get a result 60. So LCM of 6 comma 20 is 60. So here if we want to find the value of LCM, firstly we have to factorize that number and we get a prime factors. Then we have to write each prime factors of the both the numbers, each prime factors of both numbers. Then we have to write power of the greatest power of each prime factor. Greatest power of each prime factor. Then we can solve those multiples. That is the LCM of given numbers. Okay, let us see the next one. Relation between any two positive integer a and b, HCF and LCM. This is the relations. This is the relation between any two positive integer and HCF and LCM. If they given any two numbers and one of the number HCF or LCM, if they given HCF, we can easily find LCM using this formula. If they given LCM, if they given LCM, we want to find HCF, then also we can use this formula. This is the only formula given in the chapter real numbers, and this is the relation between two positive integer, a and b. A and b is any two numbers they are given, and this is the HCF and HCF and LCM. This is the relationship between the positive numbers and HCF and LCM. Explaining this with the example. For example, if you want to find here HCF, example is HCF of 28 and 72 is 4. They are given the two numbers 28 and 72. Then they are given HCF. They are given HCF is 4. If we want to find LCM, we want to find LCM. I am already told you the relation between the any two positive integer and HCF and LCM. The relation is any positive integer a into b, which is equal to HCF into LCM, right? Into LCM. Here they are given two numbers, that is 28 and 72, and HCF also they are given, that is 4. We want to find LCM. So the number 28 into 72 I am written, and 4 is given, that is written, that is HCF. We want to find LCM. Now we can write 28 into 72, which is we can cross multiply this number by here, so divided by 4, which is equal to LCM. That is the LCM we want to find. Then 4 ones are 4, 4 sevens are 28, so 7 into 72, which is equal to LCM. So 7 into 72 is 504, which is equal to LCM. In this way, we can write the numbers which is not given. If they given any two positive integer, any one of this HCF or LCM, then we if they given HCF, we can easily find LCM. If they given LCM, we can easily find HCF using this formula, using this relationship. Like in this way, we can solve HCF or LCM. In this chapter, we want to know these concepts. In the next video, I am going to discuss with you LBA questions from one by one. Thank you.